because it reflects the ocean?
No.
No, it scatters blue light. The ocean is blue because it reflects the sky. Okay, it reflects the sky because when you have overcast clouds, what color is the water? Is it blue?
Red.
Kind of a grayish, greenish color. So it's reflecting the clouds. All right, so because if the sky reflected the ground, if you were in Kansas, would the sky be blue?
No.
No, it'd be like brown. Kansas, brown. But sunsets are the same way. Sunsets is about scattering. Remember we said that most of the light, now the most scattered light is what color? Violet. We don't see violet very well. The next most is blue. But green is scattered, and yellow, and orange, and red, but not very much, and so it's not very bright, so the blue is much brighter, so we don't see the red or any other color. But what is the first color you see when the sun's starting to come up? Red. What's the last color before the sun, before everything just, you see red. And remember, that's when the sun's below the horizon. Remember, when the sun, if you were at the beach and the sun goes below the horizon, what color is the sky? Still blue. Still blue because the sun, remember, it's still sunlight, sunlight's still up there. It has to go quite a ways on that. A little faster in the winter than it is in the summer. But it has to do with this. Now, we're looking down, this picture is basically, we're looking down from the North Pole. So we're looking down on the Earth. So the Earth basically rotates this way. So Earth rotation would be that way. So this is noon. This would be evening. Morning would be on this side. So we're kind of seeing what's going on each time. Now at noon, the light rays of the sun come straight through the atmosphere, and they pass through the thinnest amount of atmosphere. How much atmosphere does it pass through? As we get farther and farther up, notice the sun, now is the atmosphere getting thicker? No, but look, but the distance, because it's hitting at an angle, the distance it passes through the atmosphere increases. Right? If I enter here and I have to go all the way to here before it touches the ground, it's traveling that far, whereas when at noon it only traveled this far. And as it passes through the atmosphere, and you read about this in that little reading on chapter 29, it bends. The light bends as it comes through. Notice it starts bending a little bit. And here it doesn't really matter, because even though it bends, we still have all the light. But we get up here. Notice, if I was standing right here, where's the sun? Above or below the horizon? Below the horizon, right? So we're seeing it bend in. And what color bends the least? Red. Red bends the least. So in the atmosphere, what happens, it kind of acts like a prism. But over here, it's doing the same thing, but there's a ray over here that supplies that blue light. So are you still seeing white light? So I have a red and a blue, it's still making white. And we're over here. But over here, notice what happened to the blue light. Before it ever got to you, it did what? It basically hit the ground. It went away. Well, if I take away the blue light, what's left? The red. The red. And in between that would be what? What's in between blue and red? Green. Green. In between is green. But this is why it starts changing. You get that blue, then it starts changing color, it gets lighter, then you might see it looks kind of pinkish and orangish, and finally it's red. It's red on that. But this is why, it's also why, what color is the shadow of the earth? Well, what color does the moon turn when it goes into our shadow? It turns red. And red. Right? A lunar eclipse, the moon turns basically blood red. What's the color of the shadow for the moon? Black. Black. We'll be a little lenient. It's not really tough, but it's black. There's no light. This has to do with our atmosphere, right? This light is bending around, so some of this light actually gets bent into the shadow. This is also why the shadow is red. If you actually were on the night side of the earth and you look back, you would actually see the earth looks like it has a rim of red around it. In other words, if you were, say, on the moon on the night side, you know, it'd be like on that side of the earth, you would see this rim of red around the edge on that. So the shortest path. But this is why it is still scattering. It's still the scattering, it's just not as much red light. We don't see it until it does that. Which also gives us the in-between, the green flash. The green flash. How many of you have seen the green flash? Yeah, probably just me. Okay, now, it's not like Pirates of the Caribbean. You know, it's big thing. No, that's not what it looks like. And the funny thing about this picture, this is actually an anomalous picture. I didn't take it. I found this, and the person who took it gave me permission to use it. This is actually taken from the San Mateo coast, which is very rare to see this. It's very rare to be able to see the green flash from land, at least from like the California coast, because you need an absolutely clear horizon, which very seldom happens on that. I've only seen it a couple of times, and all the times I've seen it was in the middle of the Pacific Ocean, mid-Pacific, where it's just nothing. Now what happens is, now as the sun goes down, if you ever watch the sun starts looking like it gets bigger and bigger. You have ever seen in the evening, sometimes when the moon comes up, it looks really, really big, and then later on as it gets higher, it gets smaller? Well, that's because the atmosphere, along with the bending, it kind of acts like a big magnifying glass. And it makes it look big. And actually, when the moon is really big, sometimes it's below the horizon. When you see the sun really big like this, it's actually below the horizon. You're actually kind of seeing an image that's being projected up. Well, as that image comes down, just as this image goes down, you might see a little flash of green. That's all. It's almost like someone just took it like a photo flash thing. That's all it is. Just it's very sometimes it's like you see, did I just see that? But you got to be looking right in the right place. In fact, it happens in the morning. It does happen just before the sun comes up. But you got to be looking exactly where the sun comes up. And obviously in the morning, you know exactly where the sun's going to come up. So if you saw it in the morning, it's just by dumb luck you happen to be looking in just the right spot. All the times I've seen it, we're in the evening, so you can watch the sun. You know, you can spend time on the bridge of a ship. When you're in the middle of the ocean, you know, it's like you're on the bridge. There's nothing there. I mean, literally. You know, we would go days without anything coming within 100 miles of the ship. So the radar would go out 100 miles. So we, you know, and invariably, if we saw one ship, invariably we would actually have to turn to avoid them because they were on a collision course. It never failed, like Murphy's Law. One ship out in the middle of the ocean, and they're going to come like that if you don't move. Just one of those things. All right, so this is the green flash. So any question about why the sky is blue, why sunset's red, it all has to do with scattering and bending of light. Which leads to the color of water. This is not the blue of the sky. The water is not blue. Blue. Well, we have to think about water. Water is resonant with infrared light. Remember how glass is resonant with ultraviolet? So any ultraviolet that hits glass gets absorbed. Water really loves infrared light. Any infrared light that touches water is absorbed. The next absorbed color is red. And we say 100 feet. Basically, by 100 feet, all the red's gone. It will be absorbed. By about 300 feet, all the light's absorbed. You get down to about 300 feet, there really is not much light. Well, let's think, if we take away red, what's left? Well, if I have white light, I take away red, what's left? Well, cyan. They're red and blue and green. Cyan. Ever go to the Monterey Bay Aquarium and you look in the big tank? If you look like way in the back of the tank, everything looks kind of what? Looks kind of cyan. Again, because that white light is being absorbed and it's just the cyan. Not the ones like right up against the window, but you look at that shark way in the back of the tank, it has that kind of cyan tinge to it because all that red light is being absorbed. So everything's cyan a little bit on that. And when you dive, this is why you watch divers, and they're diving during the day, and you'll see they have flashlights with them. And you're thinking, why is he carrying a flashlight with him during the day? Well, put light back. I remember diving one time. Saw this little green sea cucumber, little green guy. I put my light on it, turned bright yellow. Why? Because the red was gone. If they appear yellow, and I take away all the red, what color are you left? Well, what makes yellow? Red and green. If I take away all the red, all that's left is green. But when I put my white light on it, it turned yellow. I mean, it was like lemon yellow. It was like this color. But underwater, it looked kind of darkish, greenish color, which is probably good for it because it blended in. When it was yellow, it didn't blend in. You know, believe me. It's like a lot of animals. I've had a lot of crabs and stuff. They look kind of brownish on the bottom. You hit them with a flashlight and they're red. They are red coming out. All those Dungeness crab you might see when they take them out, you know, they're kind of red and brown. The bottom of the ocean, they are pretty much kind of really dark brown color and they kind of blend in. You know, they don't turn bright red until you cook them. You know, you go to this thing, they're all bright red. That's after cooking. When they're natural, they do have some reds, kind of red and greens and stuff like that on the bottom. But this is water. Questions about water? Again, we're removing red. What does it leave? Cyan. All right. Comic spectra. This is our last thing, and we're actually going to look at the spectrum next time. So we have a spectrum. Now the sun produces a continuous spectrum, those Roy G. Biv colors of the rainbow. But atomic spectra are kind of the element's signature. And you get little bright lines. Sometimes we call them bright line spectra. Little bright lines. And those of you who have chemistry have probably seen this. You get little spectroscopes out and things like that. And the spectroscope is a device to detect and measure these spectra. Basically, it brings them out. And different elements each element has its own unique set of lines. And we talked about this a little bit when we talked about mercury. So this is their signature. You know, how do they know that the sun has hydrogen and helium and these other things? Because they can see it in the spectral lines of the light. And in the light, they can see that these things are incandescent. They're putting off these things. Anyone need more time? So if we look at some of these, so the top would be the sun, continuous. Then we have something like hydrogen. Hydrogen is very famous. We call it. This actually has a name. It's called the Balmer series. Because these lines actually have a mathematical relationship. There's actually a formula that you can calculate out those lines on that. We have sodium. Remember we talked about the last, this is mercury. Remember we talked about the mercury, why mercury gives everything kind of that bluish tinge, where the white stuff on the inside that's glowing gives us kind of a continuous spectrum. But the mercury, because it puts out its own visible light itself, lots of ultraviolet, which is what makes the tube glow, but it also puts that kind of bluish, greenish light out, why everything under fluorescent lights looks a little bluish. You know, so ladies, for your prom dresses, you all kind of look at fluorescent light. That's pretty much the light that's there at the California Academy of Sciences. All right, so you know what you're going to look like. All right, questions? All right, so let's get out the concept builder. Also, each group probably needs, you might want to grab each table, grab some crayons. This is a color thing. Color, we like color. We look here. We have a shadow. So we have a white screen, and we have just a red light. And if I put my hand out, right? If I put my hand out like this, what do you get? You get a shadow. And what the shadow is? Black. Well, the same thing is going to go on here. I have this red light. If I block out the red light, my shadow is going to be black. Do the best you can. Be black, and the screen, because the light bulb's red, and the rest of the screen is going to be red. We won't worry too much. What in the hand is going to be whatever color the screen is. On that. So you can see the screen the hand also is red. So what you guys need to do is color that up. Color that up quickly. Okay, so if we look at our little light guy here, guys, we look over here. If I put the shadow in, notice where the little bar goes in, makes the shadow. We have red in the outside, black in the shadow area. But now we're going to add a green light. We add a green light here. And so we still have the same red light. So which is the shadow of the red light? The right hand, is it the left hand one or the right hand one is the red? Still the right hand one, because we haven't done anything. We've just put a green light over here now. So from the picture before, we've now added a green light. So the red shadow is over here. The green shadow is over here. But so and you can see by lines. Look. Between the red light and over here is the hand, so it's blocking the red light. But is it blocking the green light?
No.
No. So what is the color of the hand?
Purple.
It's going to be green. This hand is going to be green because the red is blocked out. Now on this side, this shadow is going to be red. But what color is the rest of the screen? It's going to be what? I think somebody said it. Yellow. The rest of it's going to be yellow. It's yellow because red and green make yellow. This hand is yellow also. But everywhere that you get to there, it's going to be yellow. And if we look at the light box, everyone look at the light box here. So I have my green light on. I have my red light on. There we go. I have the red and the green here, and when I put my shadow in, notice, see, this is the one blocking the red light, because we can see the shadow here, but in the yellow section, it's green. Here's the one part blocking the green, and its shadow is red on that, just like the screen up there. So, write down your colors on your sheet. We're going to add a blue light. We add a blue light. Let's see if it wants to be, no, doesn't want it to be nice. On that. Okay. That's what I want. All right. So, I'm going to add a blue light. Now, so the middle, so we've already decided the left-hand one is the shadow for which light?
The green.
The green light. It's the shadow of the green light. The right-hand one is the shadow of the red. The middle one is the shadow for the blue. So now I have a red, a blue, and a green light. So what is the screen going to be? White. But now, like this one, we block out the green. When I block out green, am I blocking out the blue and the red?
No.
No. So what's left? If I take white light and remove the green, I'm left with, what does it say on the back? What's the complementary color of green?
Yellow.
What's straight across from green?
Green is blue.
Magenta. We have magenta. So this one is going to be magenta. This is as close to magenta as I can get. Magenta. All right, so you guys fill in the other two. Fill in the other two. What colors they should be on this. That's as close to magenta as I have. Okay, so the blue light. We remove the blue light. What's going to be left over? I'm going to get the red, and I'm going to get the green. Once I take away the blue, this shadow is going to be yellow. It's going to be yellow. So I have yellow in this one. So that one's yellow. And then, now correct me if I'm wrong, you were in here at the beginning of SSR.
No.
You weren't. Did you go past?
I was past for leaving campus. And I just got back on campus.
Okay. That's one you were in there. All right. Now we take away the red, so we have blue and green in this one, and blue and green make
Cyan.
cyan. They make that cyan color. Just like that. All right. So if we look over here into the light box. Right, I have all three. Notice I make white in the middle. Blue is complement yellow. Red is complement cyan. Green is complement magenta. We make white in the middle. But when I move this into the middle, notice this one, I'm blocking out the blue. You can see the blue is black. Even where it crosses its complement, we get green, but we get yellow where we take away blue. Here we're taking away red, we got cyan. Here I take away the green, I get magenta. I get the complements when I take away those primary colors and things like that. All right, now keeping that in mind, we look at the next page. Now first of all, they do give you the color wheel. Remember, blue, the ones that are right across from each other, if they're right across from each other, they are complements. Complements. The complements are right across from each other. So green and magenta. So keep in mind complements. Primaries complement make white. So we have blue and we have yellow. So now we have a primary and its complement. Think about what light makes up yellow. And you need to decide, okay, one, what's the color of a ketchup bottle? Now mind you, in white light, ketchup in my world, I don't know what it looks like in your world. In my world, my ketchup is red. Well, you know, because of coloring, ketchup actually comes in a variety of colors. But I don't use ketchup that isn't red. Okay? Call me a traditionalist. You know, I think tomato ketchup should look like tomatoes. All right. Now, we have a shadow. We have this shadow. This line is the shadow. And which light is being blocked up in this line? Is it the blue light or the yellow light that's being blocked off this direction? The yellow. This is the shadow from the blue. Now, taking what you learned about the hands, you guys need to fill in what colors are in each part. Think about what shadows are where. What's going on in these two little triangles? Especially, think about that carefully. I'll give you a few minutes. Work together on that. All right, so first of all, the ketchup bottle. Now in white light, it would be red. What color is it under blue and yellow light?
Green.
It is? Well, what color does blue and yellow light make what? White. In other words, it makes white light. Remember, our blue here makes blue light. Our yellow makes green, is made up of green and red. Remember, yellow is green and red light. Ketchup bottle, ketchup. What does it do to red light? Reflect or absorb? It Reflects. What does it do to blue light? Absorbs. What does it do to green light? Absorbs. I mean, my red griffin up here, it looks red because the white light in the room, it absorbs all of the colors except for red, which it reflects. So my ketchup bottle is going to look red because there is red light in it. Right? Yellow has red. So if there is red light available, a red object is going to look red. If I put red on it, it's going to look red. If I put yellow on it, it's going to look red because you have red in it. If I put magenta light on it, it's going to look red because magenta has red. If I put blue light on it, it's going to look, another B word, black. Because there's no red in blue. If I put cyan on it, it would look black because there's no red in cyan. So as long as there's red light, it's going to look red. Remember my sea cucumber. Guys, remember my sea cucumber? Looked green. Until I put white light on it, it looked yellow because I added the red back. When I took the red away, it looked green. Put the red in, it looked yellow. Same idea. Now, this shadow. Okay, now if I'm on this line, I'm blocking the yellow light. If I'm on this line, I'm blocking the blue light. This little triangle, the two shadows do what?
Black.
It's going to be black because those two shadows overlap. So that section is going to be black because both are blocked out. But on this side, this shadow is going to be blue. Right? Because we took away the yellow, what's left is the blue. On this side, it's going to be yellow because I took away the blue. Now what about this triangle?
White.
It's going to be white. Because notice, the blue light gets there and the yellow light gets there, so this little triangle is going to be white. White. The whole front's going to be white because both yellow and blue make white. All right. Questions?